The problem with commodity processors is that although Moore's law still applies and the amount of logic available to a processor designer continues to increase, conventional processors are reaching diminishing returns in the performance increases they can get because they're attempting to extract more and more parallelism out of the same instruction set that they've been using for the last 20 years. And there's only so much parallelism you can extract out of that. Secondly, the clock rate that they can run is hitting diminishing returns based on power constraints. So with an FPGA, you can implement different types of instructions that are much more efficient and generate both more power efficiency and more performance.
So the Convey architecture provides this ability to have multiple personalities or actually multiple instruction sets. And so this is done with a FPGA file that lives on the local file system. That gets loaded by the operating system, and there's an out-of-band path to the coprocessor. So when a process or an application starts up and he's going to use some one or more personalities, those get cached on the coprocessor itself. So then anytime we do any kind of personality switching, really it's the coprocessor and the hardware. They already have the personalities cached. The application can switch between personalities on the fly, and this is all handled by the hardware.
You know, we aren't doing any ASIC developments in the design. In the past, if you wanted any decent functionality, you had to do an ASIC. Now the FPGA is just all grown up. The economics of FPGAs now are actually really good. That was effectively the enabling technology to go do this kind of computer. When you're doing reconfigurable computing, you got to have reconfigurable elements. Obviously, you only need to use the FPGAs for the reconfigurable part. We use them in a lot of other places as well. The application engines, obviously you reconfigure for the application-specific personality that you're dealing with, but we reconfigure the memory controllers based upon, you know, the use model. What kind of interleave scheme are we running? What kind of DIMMs are we using? It really gives us a high degree of flexibility. The ability to add new features. We've added some since the product was defined, and that all is because we have things that we can change without spending a 3-year design cycle and millions of dollars to get an ASIC in there. You can put a lot more things in parallel, bigger, more complex functions that you just couldn't have done. The stuff you can do is just fabulous. And the new ones, like the Vertex 6 parts that we have in the EX, are just, tremendous, right?
If having a lot of logic space available to implement a custom architecture is a good thing, having a lot more logic space is a great thing. And the HC1EX extends the capabilities of the HC1 by giving you a much larger scratch pad to work on. So you can implement more instructions, you can implement more types of instructions, you can implement much more complex types of architectures than you could on an HC1.
The main difference is really changing the application engines to much bigger Vertex 6 FPGAs. It's extended the functionality capability of things we can implement or customers can implement if they're, if they're doing their own personality using the personality development kit.